So good morning, everyone. So today the topic that I'm going to talk is about introduction to on-device machine learning. So my name is Hoong. You can call me KH. I'm the GDE in machine learning, and then I have a Twitter account using my name as a handler. You can actually follow me there. Okay, so we know that machine learning AI is a hot topic nowadays, but there's a lot of impression that the machine learning model will run on a server side using like large GPUs, or this graphic processing unit, or large TPU, tensor processing unit. But actually, at this current moment now, actually the most devices that actually run a lot of machine learning is edge devices. That is actually becoming more and more important platform for machine learning. So so as we know that one of the devices that actually run a lot of machine learning AI kind of solution services is the device that most of us will have, which is a smartphone. Okay, so let's find out that how can we actually run machine learning model on all these edge devices. First thing is when you talk about edge devices, okay, one of the features about edge devices is you have a latency. The latency have to be low because, for example, you need to process a certain video feed in real time. Therefore, you actually need a low latency to actually process the video. And actually, in that sense, definitely you need to have a way, a method where you actually run the machine learning at the edge devices. Instead of sending the data to the server and then sending back the result, that will result a delay. Okay. Second thing is a lot of time all these edge devices, they are not all connected all the time. Okay, so you have no this privilege to actually send data to the server and get the result. So without network connectivity and then you are offline, you are not able to actually run machine learning model if you're using the services from the server side. Therefore, you have to have a features where you can actually run at the device side and then without any internet connection. And of course, the last thing that people are very concerned nowadays is actually how do we provide a better privacy protection without that the data is being sent to the server, and then you don't want all the activity of smart devices being tracked. You want to preserve some sort of a privacy protection without sending all this sensitive user data to the server for processing. Okay, so with these three reasons, therefore, there is a very urgent need to actually able to run machine learning at the edge devices. So what we are looking at is you have a lot of tools or framework available out there where you can actually run on-device machine learning, where you can actually develop or create a new generation of products. Okay. So, for example, you have let's look at one example here. So you can have you have an example here where you have these features where you can actually use your camera on your phone. Then you can actually try out different lipstick color on real time. So all this machine learning identifying the position of the lips and applying the color of the lips detection. Okay, it's actually done in real time, and then the machine learning model is actually small enough after you train the model, and then you can actually deploy it at the device itself. I'm sure if you are familiar with TikTok filter and all this Instagram filter, there are a lot of things that you can actually do, detecting of the face, whatever, all are done in real time, and then without the processing done at the server side. Another thing that probably one of the tools that if you like traveling, one of the tools that I always use is Google Translate. So before I go to the respective country, I will actually download dictionary offline. Then I can actually do a Google Translate on the fly on the edge devices. So you can actually, for example, if I go to a foreign country, I can use the Google Translate offline. Then I can scan the menu. Then I can understand the menu. Then I can make an order. Okay. So now these are things that I actually can do off the model is being trained and the model is being deployed at the device. And then you can actually use all these services without any internet connection. Okay, so one of the framework that allow us to do on-device machine learning is what is actually based what we call the TensorFlow Lite. Okay, so what is TensorFlow Lite? So TensorFlow Lite is basically a framework where it's actually allow you to implement on-device machine learning. Okay, so it actually allows you to run all these TensorFlow models, okay, on the edge devices. So we know TensorFlow is one of the famous machine learning or AI framework out there, which is actually used by many AI developer or machine learning developer. But most of these TensorFlow, the model that you build is actually trained at the server side using the large GPU or TPU. Okay, but what with TensorFlow Lite is you have a framework where now you can actually deploy all these machine learning model onto the mobile devices and all the embedded devices. So with TensorFlow Lite, you can use the same model that you train, okay, and then you can have some sort of customization, and then you can actually deploy on all these devices, no matter whether it's iOS, Android, Linux, or the cloud, or even what we call the edge, these new edge TPU devices, or called Coral. I'll explain more what is Coral. So for TensorFlow Lite, as we know, it's actually supported many devices. Of course, one of the devices that most people will use nowadays is a smartphone. So no matter whether you are running on Android platform or you're running on iOS platform, TensorFlow Lite support these mobile devices. The second platform that TensorFlow Lite will support is actually all the Linux-based devices. Okay, for example, if you have all these Raspberry Pi hobbyist devices, or you have a Coral development board, is also supported by TensorFlow Lite. And lastly, you have all this microcontroller. We have a lot of embedded system nowadays. People talking about IoT, and then you have a lot of devices that's embedded. Okay, for example, Arduino. And then you also can train an AI model or machine learning model, and then you also can deploy on all these small microcontroller embedded devices. Okay, so let's go through one of the platform that we talk. So definitely, smartphone is the most popular platform for all device machine learning at this moment. So there's already like more than 1,000 plus production apps that's used globally. I'm sure if you are an Android user, you know that these are all the apps that you probably have installed on your phone, like Google Photo, Gboard, Keyboard, okay, YouTube, Google Assistant, or even other popular apps like Uber, Viber, or Airbnb. So all these devices actually, there are some machine learning model that has been already developed and they are trained, and then they are actually embedded onto the app. Okay, so all these apps is actually having the privilege of using TensorFlow model, where it's actually specially customized for smartphone apps. So as we know that more and more people are having at least one or more smartphone. So that definitely the number of smartphone devices or mobile devices out there is definitely a huge amount. So it's estimated there are more than 4 billion mobile devices globally. And then now you have this TensorFlow Lite that actually allow you to actually deploy all your machine learning model, AI model on all these mobile devices with ease. Okay. So of course, if we talk about AI model, things that are quite very popular among AI developer or mobile developer is if we talk about text classification, text classification prediction. For example, if you use a Gboard, the popular keyboard by Google, so there's a lot of autocorrect and all this next word prediction. So all this model is actually deployed onto the app, and then you can actually run all this model offline. And then we also very commonly use like Hey Google, which is Google Assistant in the Android platform, and also you have Hey Siri, which is iOS platform. So speech recognition is it's actually quite efficient and it's quite popular now. And we have come a long way where last time when we talked to all these devices is when you have different slang or different intonation or different pronunciation, it's having a hard time to understand your language. But now even our pronunciation is not very clear. All these devices are able to pick up and recognize our speech and able to convert all this speech to text and able to perform certain action based on our speech. Okay. Another popular solution that is involved AI is, of course, we talk about image. So all this object detection, object location, OCR, optical character recognition. For example, we have a lot of app that we can actually straight away scan text, then you can actually extract all the text into your Word document. So those are called OCR. Then now we have also gesture recognition, where a video webcam can actually recognize all the gesture, your hand gesture, whatever, and face modeling, segmentation. So these three areas definitely have gone a long way, okay, and then they have progressed very, very well. And all this model now is able to be trained and able to deploy onto your all these mobile devices. And then next things that's quite popular now is all this translation and also video generation. So how does the TensorFlow help with all these popular problem that you want to deploy? So if you go to TensorFlow Lite example, there are a lot of examples that already been built and trained by developer out there, and then it's being shared. So if you go to this website, you can see there's a lot of image classification that actually being trained. The model is being trained where you can deploy in Android, iOS, or Raspberry Pi. Similarly, for other solution like object detection, pose estimation, speech recognition, gesture recognition, or even smart reply. So one of the popular use is recently that is actually pose estimation. So for example, nowadays you have a lot of apps that can actually teach you how to do yoga at home, or how to improve your golf swing, or how to improve your maybe your position, whatever. So now you have a model that's already been trained out there where you can actually straight away deploy into an Android app or iOS app that you can actually estimate what is your pose. Okay, then he will tell you whether your pose is correct or wrong. Okay, and then that model is so small you can straight away deploy into your mobile devices. So we talk about API. There's a three level of things that you can start from. If you want to start using TensorFlow, you can use the high level API. So in Google, we have something what we call ML Kit. So this ML Kit actually is a high level API where you can actually deploy using this ML Kit to develop a lot of machine learning models, and then you can actually deploy on all these devices. Okay. Of course, if you want to go one level down, you can actually use the TensorFlow-like models, customized models. Okay, or if you are a Google Cloud user, you can actually use the Google Cloud and then to train your model. Later, I will show some example how to train a model using Google Cloud. Okay, and then if you go one level down, you can actually write your model in the Android Studio for Android devices, or you can actually write your model and deploy onto these Coral devices, Coral bot. So you can see for the ML Kit, it's a high-level API. There are many solutions out there that you can actually develop. You can actually develop vision-based solution. For example, you can actually recognize text. Okay, you can recognize a face. Okay, you can recognize object. Okay, then you can actually these are all the API available in terms of vision. Okay. Then there's also API that involve about language, natural language. So you can actually do translation. Okay, you can actually do translation on the fly. And then there are also other customized model that's actually available in the this ML Kit. The next devices or platform that TensorFlow Lite will support is this Linux-based devices platform or Linux-based IoT devices. Okay. So, for example, you may have a Raspberry Pi or you have a Coral dev bot. You can actually deploy your AI model onto these devices. So, if you look at one of the examples that TensorFlow Lite is being used is, for example, this EcoVac robot vacuum cleaner. So nowadays, vacuum cleaner is no longer just using a normal sensor, just a white obstacle or object in your house. You can actually now have a vacuum cleaner that with the camera, it can actually detect what are the objects that is recognized and what are the objects in the house. Okay, so it's not just avoiding the object. It can actually know what are the object that is actually in front of it, then how to avoid all these objects. Okay, for example, here you can see this object detection is actually seen real time. There are some cables or one of the common problem also when you have a smart vacuum cleaner is when you have a pet at home, like a cat or dog, it actually will disrupt. So and then object, if the static is fine, but if you have a pad, the pad will move around. So your smart vacuum cleaner will supposed to able to know that this is a pad, and then how to avoid the pad or whatever. Okay, so common object like a carpet, pad, or other object at home is actually being trained, and then it's actually deployed onto this smart vacuum cleaner, and then you can use this offline without any internet connection. Okay. Besides that, I also want to talk about another product that is actually from Google. So TensorFlow is we know TensorFlow Lite is a software solution. So Google also have a hardware accelerator where we call HDPU. So how do we improve this processing time of all these small devices without using the high processing power from the CPU side? So we have something what we call HDPU, where you can actually run the TensorFlow Lite model faster on IoT devices. So one of the HDPU that available at different form factor is under this Coral brand. So for example, we have a small devices like this, which is a smaller than 1 cent coin. And then here is actually customized kind of a board where it actually can run a TensorFlow model at a higher processing time. Okay, so Coral product has been launched 2 years ago in March 2019. Now it's available all over 36 countries through various distribution partners. So you can actually deploy all this model at this HDPU, which is Coral Dev Board, which is actually basically a mini computer, which is ARM CPU chip, and it actually run on the Linux operating system. You also can use this Linux, this Coral USB accelerator. So you have a USB kind of accelerator where you can actually plug in onto your machine, okay? And then you can actually run this accessory will actually allow you to run HDPU and bring your machine learning inferencing faster to existing system, okay? So sometimes you can have a model to run on the production. You can have a different form factor. So you can see there are many different form factors available under this Coral product brand, and it actually help to run all this TensorFlow Lite model at a higher processing time. Okay, so you can see there are DevBot Mini being prototyped, and then there are other production like this HDP model. Okay, and then you have some PCI card where you can actually plug in onto your computer, where it's actually improved the processing time without using the TPU at the server side or GPU at the server side. So you can see that one HDPU can actually give you up to 64 top inferences performance, and it actually use quite a low power, which is about 40 watt peak power. Okay, the last platform that TensorFlow Lite will support is actually all this microcontroller, which is Arduino board. Okay, so what is a microcontroller? So basically, it's a small computer on a single circuit. There's no operating system. It's actually bare metal. Okay, it's actually very small kind of storage. You only have like tens of a kilobyte of RAM or flash. It only have a CPU, memory, and some I/O peripheral. It runs on very low power. Sometimes it just runs on small battery, and it's always on. Okay, so this sometimes is also DSP, digital signal processor, where it's actually specialized to process certain audio, certain video. So when you have devices which has so low power, such small, okay, how can you run a TensorFlow model with them onto all these devices? Okay, so what's the best way to run all these machine learning AI model onto all these devices? So with TensorFlow Lite, it's actually allow you to run to have a model to be trained and then compressed at a very small size and actually run on these devices. Okay, so I think most of us are using Android phone or iOS devices. We find that all these hot word detection is quite efficient now. You can just use your phone and just call Hey Google or Hey Siri, and the hot word, even if you have even a smart home speaker, it actually detect your voice and actually detect your voice and wake up, okay, with your voice command. And then you can see all this hot word detection actually can work without any internet connection, and then it actually wake up very fast. So that's where you have a small chip that actually inside your phone that actually pick up all these hot word devices, and they wake up at a very fast speed. Okay, so TensorFlow actually make the embedded AI now easy for developer. So let's say you are a TensorFlow developer, you already been developing AI solution using TensorFlow. You can now just repack into your TensorFlow into TensorFlow Lite using the TensorFlow Lite framework, and then you can deploy in multiple devices, different run a model in different devices with the same tool and framework that you have been using from the beginning during the TensorFlow time. So that for developer, the good thing is you have the same tools, same framework. Then you do not need to manually build all your model, and then you have all the hardware level optimization already done for you. So there are a lot of devices out there that has the hardware that's optimized the performance. So there are many industrial leaders, for example, in the ARM, which is actually industrial leader for the embedded market, that's actually adopted TensorFlow as an official solution for AI. Then there are ARM microcontroller, for example, Cadence, Knowledge, Synopsys. These are all the microcontroller that actually optimize the model for TensorFlow framework. So how to get started? You can actually go and look out all these official Arduino library, and then you can actually run your code directly in the desktop or the web IDE, and then you can actually run onto your Arduino hardware. For example, you can actually look at one example. You can actually do speech detection in 5 minutes. You can actually run your speech detection in 5 minutes. Then you can actually try out the TensorFlow Lite framework. Okay, so TensorFlow Lite is actually optimized for edge devices. Basically, how do we do it? Okay, how do we optimize the machine learning model to be able to deploy edge devices? So basically, what we do is we make the model smaller and faster. Okay, so optimization is important because we know edge devices, they are limited computing power, they are limited memory, they are having a very small. You want to limit the battery consumption because sometimes they are running on the battery. They are put at a very remote location. IoT devices, you cannot have a model that actually drain up the battery very fast, and then you need to have a model that actually run a very small size. So based on all these constraints, you must have a model to be able to be trained and deploy, and then based on all these constraints, your model still acceptable and still produce good result. Okay, so one of the methods that people will do is you have a optimized model where the model is optimized for mobile architecture. Okay, and then what the second thing what we do is we apply quantization. I'll explain later what is quantization, and then we apply pruning. Okay, then lastly is we'll use whatever hardware accelerator out there, okay, to improve the performance. So let's look at the first one, model architecture. So if you look at the model architecture, this is if you are familiar with deep learning framework architecture. So with Inception version 4. So if you talk about the accuracy, you actually can achieve about 95% accuracy. So this red color here, is actually a model that's actually trained for normal hardware architecture. But if you have a TensorFlow Lite, you can actually retrain your model into for mobile devices. Okay, of course you can see the accuracy will drop a bit because you make your file size smaller will actually run, but the difference is only 6% in terms of top 1 accuracy. In terms of top 5 accuracy, the difference is only 3%. But what's the difference when you run on the TensorFlow Lite latency? Before that was 320 milliseconds. Now the latency is only 8.58 milliseconds. That means you actually improved 37 times faster. And another thing is you look at the model size is 170 megabyte here, and then now you're able to compress it into a smaller file, which is about 8 times smaller. So if you look at the comparison, you can see the comparison here that the difference between the accuracy between the normal model and the mobile net model is not so far ahead. Okay, it still achieve a reasonably good result. Then the second method that is called quantization. So basically, quantization is when you build a model, you train a model. Basically, you use the 32-bit float type. Okay, to store all your model with. Okay. However, when you use the inference, okay, if you use this 32-bit float, okay, you can actually approximate it down to 8-bit. Then the model, so for example here, we can actually, what we try to do is we can actually reduce the number of bits that we use, but you can still achieve a certain good result. So the quantization basically is to reduce number of bits for the model weight activation. Then you can actually shrink down the size to represent the amount of data size to represent your the width and your activation in your training model. So normally, once you use your quantization, your model will become 4 times smaller and run faster. Okay, so if you look at here, okay, this is the baseline. Okay, if you do quantization, you can see the accuracy actually drop not so much. The difference is not so much, but the accuracy doesn't change so much. But you actually reduce the amount of data that you actually require. Then you will reduce the model file size. The third step is how do we you do pruning. So if you know that when you talk about machine learning, we talk about deep learning, you talk about all this neural network. Okay, so neural network, if you talk about deep learning, the network, you have many layers. The more layers, the more calculation you have to do. Okay, so what you do by pruning is you can try to reduce some of the layers. Okay, or try to drop some of the layers. So when you drop some of the layers, then the amount of data that you need to calculate also will be lesser. The model file size also will be smaller. So you try to shrink the model, okay, by reducing number of layers. That's called pruning. So what's the benefit of doing pruning? So you have a model smaller, okay, and then your model also runs faster because you have a reduce the number of layers, and then you have smaller model, so your model can run faster. Okay, so you might say, if I reduce the number of layers, what will happen to my accuracy? Okay, so the accuracy is actually, you can see smaller accuracy, but you can see the result is actually 89 compared to 70. It is 69. So you see the accuracy actually doesn't drop so much. Okay, it's quite negligible if you talk about that. So you can still have a model with a smaller file size without sacrificing the accuracy. The last thing that for mobile devices you will have is what we call, you can optimize for your hardware accelerator. So this is a normal CPU using your normal computer. The normal processing time will be about 37 milliseconds, and then the latency is about 37 milliseconds. So if you use a better CPU with a quantized, you improve to 13 millisecond latency. Of course, if you have a high GPU, the latency is 7 milliseconds. But then if you have an HTPU, okay, remember all this, the sound of this microcontroller board which optimized, you can see the latency is 3.2 milliseconds, even better than your GPU. And then if you use all these specialized microcontroller like Hexagon, you can see the latency about 2.8 milliseconds. It's even faster than your CPU. So you can see now with all these devices, even though the size is smaller, okay, but with all this optimized hardware accelerator, okay, you can see the performance is actually comparable or even better than your GPU or CPU. So there are many ways to get started. You can actually get all your pre-trained models. So instead of train all the model from the beginning, get all the data, you can actually look at all the model available in the TensorFlow Lite website. Okay, there is also a TensorFlow Lite hub where there's like a GitHub where all the model is being shared out there with all the codes. Okay, and then there's something compiled by another GDE, Margaret. She is a GDE in machine learning. So she actually compiled all the TensorFlow like example, which is called Awesome. From here, you can actually learn all the code model sample tutorial for all the code where you can actually utilize the ML kit, Coral HTPU or Raspberry Pi or for microcontroller. Okay, so what are things that you can do? You can do image segmentation. For example, here, if you try to reduce this two lady, you can detect that this two lady is the foreground and then this all the other background. So you can actually detect and then you can segment out. Then you can actually remove this background, remove this person from this image here. Okay, image segmentation is one of the models library that's available in the TensorFlow website. Okay. Then you can do, like, for example, here you can actually straight away have a bokeh effect. So I think these are things that you can actually see at the most video conferencing application now. Okay. For example, if you run a Google Meet or you run Zoom now or Microsoft Teams, straight away you can actually apply the filter, can actually blur your background. So those are another example that you can actually run all this detection of you as a foreground and then what's the background and then blur the background so that you can actually apply bokeh effect. Here, similar things. You can actually detect the foreground, and then you can actually replace your background. Okay, it's the same thing that you can actually see at the most common video conferencing software now. You can apply different background into during the video call. This is also done with using AI model where you can actually detect the foreground and background, and then you replace the background with the wallpaper. Okay. So lastly is just give you an example how to train a model using Cloud AutoML. So let's say you are a Google Cloud user. Okay, you can actually train your model using Google Cloud, the Google Cloud AutoML. So Google Cloud it has a service called AutoML Vision Edge Detection. So what you can do is all you need to do is prepare your training data. As we know, whether you're doing machine learning or you're doing AI, you must have your data. If you don't have the data, then you cannot train your model. So you train then after that, you can utilize the Google Cloud to train your model, and then you can deploy your model in the Google Cloud, okay, using like an API call or what. So for example, here, let's say I want to train my camera to detect different type of flowers. So we know that one prerequisite to train a machine learning model must have a label data. So for example, here you have all the picture here, image picture, then you label them. So this is a rose, daisy, tulip, okay, sunflower. Okay, so you have your image with label ready. You upload all your images into your Google Cloud. So here, for example, you have 3,667 images, and then you have them labeled. So from here, you can see what are the ratio. So for example, you have around 898 picture of dandelion. Then you have 640 picture of roses. Then 697 picture of sunflower. So after that, what do you do? Then you actually define your model. Then you say you want to train your model, and then where do you want to host your model? So let's say you want to train your model, and then you say you want to host it at the offline or mobile devices. So what the Google Cloud will do, he'll know that you want the model to be small, okay, and able to later you can able deploy into all these mobile devices or edge devices, okay. Then you can set how much of optimization you want to do. Okay, you want to achieve a very high accuracy. Of course, when you want to achieve a high accuracy, usually the model file will be slightly larger. Okay, and then you have a higher latency. Let's say you do not want to have a high accuracy, then you can actually have a trade-off. Then you say I can have a lower latency, so you can reduce the file size. Accuracy is only medium, but then you reduce the latency also. So latency you can reduce by half. The file size also reduced by half. Of course, if your device is very, very small, but what you care is just fast prediction, then you can even go further for faster prediction. Then your file size is very, very small, about only 0.6 megabyte, but the accuracy is low, but the latency is also very low. Okay, then you can train your model. So after you train the model, then you can actually deploy the model. Okay, so what you do is now you can actually export. Once you train your model, then you can export your model as a TensorFlow Lite package. So once you have a TensorFlow Lite package, then you can actually deploy into your mobile app. Okay, so for example, here you can just if you are Kotlin developer or you can actually insert the code into your okay, you can insert your code into your Android Studio or use a Kotlin. So what are the supported use cases? For example, here you can able to detect banana at 98.82%. Okay, then here even got multiple object, you're able to detect the object apple. Okay, and then able to also detect hat. Okay, so you can see you have 1, 2, 3, 4. Here got 7 apple. You have 7 apples, and then you also can detect the hat. Okay, so object detection can be done. Image classification also can be done. Okay, so I think that's the end of my talk. So I thought Jesselyn said I activated his Google Home several times. Okay, let me try again. Hey Google. Okay, so you can find out more. You can find out more about TensorFlow Lite at this website, tensorflow.org /Lite. You can learn more about that. Okay, if you have more questions, you can follow me in Twitter. You can ask me a question on Twitter also. Yep, that's the end of my presentation.
Thank you. So we have a few questions from Sindrosa, and Sindrosa says, I'm very interested on deploying Coral on edge inspection machine. And the question is, how common is the use case for converting ONNX to TensorFlow Lite?
Actually, the conversion from TensorFlow framework to TensorFlow Lite is quite common, but ONNX, I'm not very sure about that. I need to look at it. Usually, the conversion from a TensorFlow trained model, the bug is lesser to TensorFlow Lite, but I'm not sure about the converting from ONNX to TensorFlow Lite. I've not tried it yet. Yeah.
Okay, thank you. And there's another question. So can you use knowledge distillation to close the accuracy gap between a big or a small model?
You can, but you have to do it at the TensorFlow the model side. You usually the TensorFlow Lite, there's no more optimization that you can do. You need to do train and then optimize it at the TensorFlow framework side, not the TensorFlow Lite side. The TensorFlow Lite side usually just repackage into a on devices application. Then you just deploy. Not much of things that you actually can do at the TensorFlow Lite side.